Have you ever looked up at the sun and felt its warmth on your skin? That warmth is energy. Now, what if I told you we could use that same energy to push a spaceship across the vast, empty darkness of space? It sounds like something straight out of a science fiction movie, doesn't it? Imagine a giant shimmering kite catching rays of sunlight and gliding silently between planets. Can a spaceship really fly without a single drop of fuel? With no big, fiery rocket engines to give it a push? It seems almost like magic, but this incredible idea is very real. Scientists and engineers all over the world are working on it right now. The short answer is a big, resounding yes. We can absolutely travel through space using nothing but the power of sunlight. This amazing technology is called a solar sail. Think about a sailboat here on Earth. A sailboat has a big sail that catches the wind. The wind is just moving air. As it pushes against the sail, it moves the whole boat forward across the water. A solar sail works the same way, but instead of catching wind, it catches sunlight. We don't usually think of light as something that can push things, but it can. It's a very gentle push. Out in space, where there's no air to slow you down, even the tiniest push can make a big difference. This isn't just a wild dream, this is real science, and it's already happening. Humanity is figuring out how to harness the sun to explore new frontiers. Instead of packing our spaceships with heavy fuel, expensive fuel, limited fuel, we can just unfurl a giant reflective sail and let the sun do the work. This opens up new possibilities for where we can go and what we can discover. So, what does one of these amazing solar sails actually look like? Picture a gigantic, super thin, ultra-shiny sheet of material, almost like a massive piece of aluminum foil or a giant spacefaring kite. These sails are designed to be incredibly large so they can catch as much sunlight as possible. We're talking about sails that can be as big as a football field or even larger. But even though they are huge, they have to be unbelievably lightweight and thin. In fact, some solar sail materials are thinner than a human hair. This is super important because the push from sunlight is so gentle that the spacecraft needs to be as light as possible to get moving. The material used to make a solar sail is very special. It has to be highly reflective, like a perfect mirror. The more reflective it is, the more photons will bounce off it, and the more push the sail will get. Scientists use materials like mylar, a specially coated plastic called CP1. These materials are not only shiny and lightweight, but also very strong and durable. They need to be able to withstand the extreme temperatures of space scorching hot when facing the sun freezing cold when in shadow. The sail is usually stretched out and supported by long, lightweight booms. Getting a giant, delicate sail into space is a pretty big challenge all by itself. You can't just launch it fully opened, of course. It would be far too big and fragile to survive the rumbling, powerful journey through Earth's atmosphere on top of a rocket. So, engineers have designed these sails to be folded up very tightly, kind of like an origami masterpiece, into a very small package. For launch, the entire sail assembly might be no bigger than a shoebox or a small suitcase. Once the spacecraft is safely in orbit, far away from the air and friction of our planet, it receives a command from Earth to begin deploying or unfurling its magnificent sail. The process of unfurling is a slow and careful ballet of technology. The booms extend, pulling the sail material taut until it's a vast, flat, shimmering surface, ready to catch the sun's rays. It's a breathtaking moment when this giant structure, packed into such a tiny box, reveals its full size. Once the sail is fully deployed, it becomes the spacecraft's engine. There are no moving parts, no fuel to burn, and no loud noises. There is only the silent, constant, and gentle pressure of sunlight, pushing the craft on its journey across the solar system. Let's dive a little deeper into the amazing science of how sunlight can actually push something. It all comes down to those tiny particles of light we talked about, photons. Visualize photons as tiny basketballs hitting a person on a skateboard. Close on skateboard, friend throws basketballs. Basketball hits and bounces. Skateboard rolls back a little. Now imagine millions and millions of tiny invisible basketballs hitting you every single second. That's basically what happens with a solar sail. The sun sends out a massive stream of photons in all directions. Solar radiation. Streams of photons leave the sun toward a spacecraft. When photons hit a shiny solar sail, they bounce off just like the basketballs. Diagram of photons bouncing off a sail with arrows showing force direction. Newton's third law, for every action there's an equal and opposite reaction. Close diagram, bouncing photon transfers momentum to sail. Small force pushes the sail away from the sun. Label, radiation pressure. On Earth, this pressure is overwhelmed by gravity and air pressure. In space, there's no air drag and almost no gravity once in orbit. Even a push as gentle as a feather can have a huge effect over time. The push from sunlight on a solar sail is constant. It never stops. As long as the sail is in sunlight, it is always being pushed, 24/7. The spacecraft is constantly accelerating, going faster and faster. What's even cooler, you can steer a solar sail spacecraft. Sailor tacking a sailboat analogy. Space sail tilting to change angle relative to the sun. Tilting the sail changes the direction of the photon push. Spiral away from the sun. Spiral inward toward the sun. Change the shape of its orbit. All this control without using a drop of fuel makes solar sails incredibly versatile for exploration. This isn't just a cool idea on a whiteboard. We have actually sent solar sails into space and watched them fly. One of the most famous and successful solar sail missions was a Japanese spacecraft called Icaros. Launched in 2010, Icaros was the world's first spacecraft to demonstrate solar sail technology in interplanetary space. It deployed a beautiful, square-shaped sail that was about 20 meters or 66 feet from corner to corner. It was an incredibly exciting mission for scientists and engineers around the world. The Icaros mission was a huge success. After its sail unfurled, mission controllers on Earth confirmed the spacecraft was actually accelerating, exactly as they'd predicted. It was proof this technology worked. Icaros sailed on its journey through space, flew past Venus, and continued its voyage through the solar system. The mission showed solar sails can provide propulsion, and you can steer by adjusting reflectivity across the sail, a way to control orientation without thrusters. Another amazing example is from the Planetary Society, led by my friend Bill Nye, the science guy. They launched a small spacecraft called LightSail 2 in 2019. The mission was funded by thousands of space enthusiasts worldwide. LightSail 2 was a tiny satellite, about the size of a loaf of bread, with a mylar sail covering 32 square meters, or 344 square feet. Its mission? Show a small satellite could raise its orbit around Earth using only sunlight, and it worked beautifully. After release, LightSail 2 successfully deployed its sail. Over the next few months, by carefully turning its sail to catch sunlight at the right moments, the craft slowly raised its orbit. It got a tiny push, lifting altitude a bit higher. The mission proved small. Inexpensive satellites can maneuver this way, opening new possibilities for future missions. LightSail 2 was a testament to the passion and determination of people who believe in space exploration. So why is this technology so important for the future of exploring our universe? The biggest reason is fuel. Traditional spacecraft are like cars. They have a fuel tank, and once that fuel is gone, the journey is over. This severely limits how far we can go and what we can do once we get there. We have to plan missions very carefully because we only have a limited amount of fuel for changing course or slowing down. But a solar sail doesn't need any fuel at all. Its fuel source, the sun, is always there, providing a virtually endless supply of energy for propulsion. This unlimited fuel changes everything. It means we can design missions that last for many, many years, or even decades. A solar sail-powered spacecraft could travel to the outer planets like Neptune, or even venture out of our solar system entirely, continuously accelerating the whole way. It also allows for missions that would be almost impossible with conventional rockets. For example, we could create a satellite that hovers in a fixed position over the Earth's North Pole. This would be fantastic for observing our planet's climate and weather patterns in a whole new way. Solar sails are also perfect for sending swarms of small, lightweight probes to explore different destinations at once, like visiting multiple asteroids in the asteroid belt. Since they don't need to carry heavy fuel, the spacecraft themselves can be much lighter and cheaper to launch. This could make space exploration more accessible and allow us to conduct more science for less money. Imagine sending hundreds of tiny sailing probes out into the solar system, each one on its own journey of discovery. The amount of knowledge we could gain would be absolutely incredible, helping us piece together the history of our cosmic neighborhood. In summary, solar sails represent a giant leap in how we think about space travel. They are a form of elegant propulsion. They are a form of patient propulsion. They are a form of persistent propulsion. By harnessing the gentle, unending push of sunlight, we can break free from the limits of a fuel tank. These shimmering giant sails will allow us to embark on longer, more ambitious journeys to the far reaches of our solar system and beyond. The future of space exploration might not be loud and fiery, but silent and graceful, as we learn to sail the cosmic seas on beams of light, forever pushed forward by our very own star. If you learned something new, hit like and subscribe.